Good afternoon, everyone.
Hi.
Hi.
Hi. Did you prepare System Verilog and UVM? I already shared the assignments and interview questions. Did everyone revise the concepts?
I'm joining for the first time today, so I know the basics, but yeah, I have not revised much.
Okay. What about remaining Jivita, Sachin, Srikant, Pragna,
Yeah,
Uh,
ma'am,
Jaren?
I
somewhat
only did actually.
revised.
Okay. I have shared nearly 15. Mm-hmm. Okay. So, did you have idea, good knowledge on UVM?
My UVM basics are means SV I have good idea, but UVM I need to prepare more.
Okay, okay. So today we are going to have a discussion on System Verilog and UVM because we already completed your protocol in Verilog HRL I2C protocol specification. I2C protocol we are going to implement in System Verilog. Tomorrow we are going to write the test bench, right? So for that purpose, we first have a quick revision on System Verilog so that you can revise your concepts. I think you have learned last a few months ago, I think so that's why we'll just have a revision. And even UVM also, because AHB and AXI we are going to implement in UVM, right? So today we'll have some discussion on both. So okay, so is my screen visible?
Yes, ma'am.
Yes.
Okay, so interview questions discussion on System Verilog and UVM. So first of all, what is the main difference between Verilog and System Verilog? Can anyone tell what is the main difference between Verilog and System Verilog?
Introduction
Yeah,
of
sure,
OOPS
ma'am.
concept.
Okay.
Yeah, SystemVerilog is a hardware description and verification language. It is built on top of Verilog. Um, SystemVerilog primarily used in design and verification of digital circuits and systems like process and memory units.
Okay.
In earlier days, we will use for verification. We will use Verilog test benches. Those were very small, um, easy to apply stimulus and checked outputs.
Okay.
And it has a very low reusability and hard to scale for complex designs. So
Mm-hmm.
Verilog has a very low reusability. For every project, we need to build the test bench from scratch. And also, Verilog introduced like basic data types like reg and wire. These are enough for design simple hardware. But in order to test the modern hardware, we need more advanced um, data type. That's why System Verilog introduced data types like logic, struct union, and the enum data type def. And also,
Okay.
SystemVerilog added advanced features like classes, object-oriented programming, concepts like inheritance, polymorphism, encapsulation, making test benches more structured and reusable and scalable. And also,
Okay.
SystemVerilog supports constraint randomization. In Verilog, we have a disadvantage in randomization concept. It doesn't support constraints in Verilog. There we will use a simple built-in method like $random. For each and every variable, we have to assign $random. That is very time consuming, and also sometimes it will repeat. It will generate the repeated values. In that case, we cannot. Uh, uh, we cannot check the other corner cases and another situation. That is one of the disadvantage in Verilog. But System Verilog supports constraint based randomization. With that, we can check all the corner cases and it will generate some meaningful values. And also, it will
Okay.
control the randomization process. And System Verilog supports coverages and how to measure the design verification, and also assertions to check the design behavior. And these are some of the advantages when compared to the Verilog.
Okay, good. Remaining any answers?
I think she covered
Jeevita
most of it.
prepared full. Okay. Still any topics left? So first of all, Verilog is a majorly used for hardware purpose, for RTL design purpose, and it have less constructs for verification. Okay, and whenever the complexity of design is increasing, suppose in real time, we don't just use a simple full adder or flip flop or just a finite state machine or just a memory. In real time, we use some system on chip design where the circuit is having different types of functional blocks. Like there will be some subsystems and there will be some IPs and the there are some protocols are nothing but which are interconnected here. Okay, so just a second. Protocols are nothing but the connections between different subsystems and the IPs. Okay, so whenever we are connecting multiple blocks at one chip, the verification plays a major role because the lacks of signals, the lacks of variables are involved in each IP, and also these all are dynamic environment because everything doesn't like if it is a static environment, every time we need to write the code from scratch. Okay, but if it is a dynamic environment, example like a class based verification, if we do the if we use the object oriented programming, we can reuse the code, we can recreate the code, and also more flexible. Okay, so first of all, that is the main advantage, which is a dynamic environment. System Verilog is a dynamic environment so that we can change everything in a runtime. Okay, what is mean by runtime? What is mean by runtime? For example, we are the functional verification engineers, right? So functional verification engineer is nothing but we need to verify the functionality of a design. That's what the major intention. Okay, so functionality of a design, in the sense, suppose there is a full adder. Full adder have its own functionality, that it add 3-bit data and it generates sum and carry. That's what the functionality. Multiplexer have a functionality like it have n number of selection lines, 2 power n number of inputs and one output. We need to write the output expression or logic gate. Even adder have its own functionality. Suppose this is what the simple adder I have generated in a circuit netlist. Okay, so input A, B, output will be Y. So whenever I designed this in RTL, I got this logic circuit. Okay, I felt that okay, this is what the circuit diagram it generated correct, but we don't know exactly whether it is working correctly or not. So when we should know, when we get to know that circuit is working correct, whenever we apply the test inputs, test vectors or input stimulus, and verify the design in all corner case scenarios. Okay, suppose it's a 2-bit means 2 power 2 corner case scenarios, that means 4 cases we need to verify. If it is a 3-bit 2 power 3, 8 cases we need to verify. If it is a 32-bit 2 power 32 number of scenarios we need to verify. Okay, so whenever we verify every corner case scenario, then our functionality, if there are no errors, if the output is getting correct for every corner case scenario, then our design is working correctly. That's what the that's what the functional verification engineer do. Okay, so in that case, whenever the complexity of design is increasing, it's not possible to use Verilog. Why? Because there are a lot of limitations, like in terms of data types, if we consider arrays, if we consider parallel execution, like in system Verilog we have fork, join, any, none, all, even wait, fork. And also there are object oriented programming in system Verilog, randomization, which is most important. Okay, so because of all these things, Verilog is not much preferable to do the functional verification. Okay, understood everyone? Runtime in the sense here, suppose there are 1,000 number of test cases. Okay, all test cases may not run or may not end at the same time. Some test cases will complete run in 1 hour or 2 hours, one day or one week. Okay, so that's what the test case we call as a runtime. So as SystemVerilog is a dynamic environment, if anything is reusable or rechange, we can do everything in a runtime. Suppose there is a array concept in Verilog HDL. In Verilog, we have only static array. That means once it is declared, we cannot resize. Okay, suppose here A I have declared as a 3-bit, B I have declared as a 3-bit or 4-bit, 3 down to 0. C also I have declared as a 3 down to 0. But whenever I am doing some operation like 16 into 16 or 16 plus 16, the C may not able to store this 3-bit data or 4-bit data. Then what I need to do in runtime, I need to recreate the size of C variable. Okay, but in Verilog HDL, once this C is declared as a 4-bit data, we cannot recreate the size. Okay, but in Verilog HDL, we have a dynamic environment where we can recreate the size. Did you remember the syntax for dynamic environment? How can
Yes,
we
ma'am.
recreate the size of the dynamic environment? Jerin, can you answer? First of all, I want to create a memory with the 5-bit. How can I create this 5? A memory. And this 5, I want to resize with the 10. How can we resize? What are the syntax? Syntax is most important. Hmm? Remaining Pragna.
A is equal to array of 5, and then
Okay.
A is equal to new of
A
whatever the
is
size,
equal to array of
array of
5.
5,
Okay.
and then again A
Okay.
is equal to new
Okay.
new of
New.
10 of 10,
Okay.
and then array. Previous
Okay.
also A
So,
is, yeah.
mm, okay. So, if you see here, array of 5 in the sense, it just create the 5 locations. Okay. 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. Till 4 only. So now we are storing some data based on you can directly put array of I is equal to some data using this operator 0, 1, 2, 3, 4. Like this also you can store some data. Okay. So now this file size is not sufficient. Okay. Then what we are doing? We are just using a new of some value 10. Okay. So it will just recreate that, not recreate, it just extend 5 more locations to this 4. Okay, 5, 6, 7, 8, 9 till 9. So whenever we are resizing the array, if you want to store previous data, then whatever the name you have used here or whatever the variable you have stored before, that variable you need to put here. Then it will resize the array and also it will restore the previous data. By restoring the previous data, it just extend the array. Did you understood everyone?
Yes.
Yes.
Okay. Suppose next associative array. What is the associative array?
When we don't know the size in advance, at that time associative array is
Hmm.
preferable.
Okay.
Here,
So before in dynamic array, we can recreate the array, resize the array if the size of the memory is not sufficient. But sometimes we don't have any idea how much memory it will be allocated for some functionality, for our functionality. That time we just create a array by putting some data type or some star, so that the some spare memory is allocating to this array. Okay, now you can use for the functionality to do some functionality. After completing of functionality, whatever the size it required, whatever size it occupied, based on that it will allocate the memory size. This, that is what the associative array. Everyone understood? Like that there are different features like oops, concepts, randomization. We will discuss one by one. Okay, that is why the Verilog is not much preferred. Why? Because it doesn't have the proper constructs to do the functional verification in SOC level or IP level whenever the design complexity is increasing. Okay, any other doubts remaining? Okay. Next is SystemVerilog Testbench architecture. Can you explain anyone? What is the
Yeah,
SystemVerilog Testbench architecture?
yeah. Testbench top is a top level component that connects interface and DUT. And test initiate the environment component. Environment consisting of mainly four classes. One is generator, driver, monitor, and scoreboard. Generator generates the randomized stimulus according to the transaction class and stores into the mailbox. Driver receives the randomized transaction from the generator and drives them to the DUT as a pin level activity. Monitor observes the pin level activity and the connected interface at the input and output of the design. And this pin level activity again converted into a transaction packet and sends to the scoreboard for checking purposes. The scoreboard receive the transaction from the monitor and then compares it with the expected values, whether it will compare whether it will match the actual output with the expected output or not. These are
Okay.
the main components.
Okay. Remaining, can anyone answer? Hmm? Remaining. Did you not prepared? Okay. So this is what the architecture of System Verilog test bench. Okay. So in Verilog HDL, we don't have proper structured architecture to do the verification. But in System Verilog, we have proper structured architecture where we can reuse the code for any dynamic environment for any RTL design. Okay. So of course, it's a complex verification environment, but for proper functional verification to cover all the corner case scenarios in every in every functionality or any feature, we have proper test case where we can convert this into the number of test cases. Okay, so if you see, there is a DUT. This is what the DUT, nothing but RTL design. Okay. In Verilog HDL, how the DUT is connected with the test bench? Did anyone remember how the DUT is connected with the test bench?
By doing module instantiation.
Okay. The design module instantiation we do in the Verilog HDL test bench. Whatever the proper test bench we have considered for that particular design, in that design we write the DUT. That's what normal interface that is static in nature. Okay. But in System Verilog, how the code we write? First of all, we will start with the interface. If anyone don't know how to write the System Verilog test bench architecture, anyway tomorrow I will explain entire architecture. Before I am just explaining you how to write. Okay. So first of all, every time we need to start with the interface and end interface. Okay. This is what the first block we need to write. Why? Because if you see here, the test bench, the DUT is connected with the interface first. Okay. So in System Verilog, what we need to write within the interface?
Variable
Hmm?
declaration using logic keyword.
Okay.
Inputs,
So
outputs.
what are the different types of data types are there in System Verilog? Can anyone tell other than Jeevita? What are the different types of data types are there in System Verilog?
Bit, byte, int, logic.
Okay. Still, what? Hello.
enum struct.
Okay. What is the difference between enum and a struct?
Union also is there.
Okay. What is the difference between union and a struct? Hmm? Okay. See, in SystemVerilog we have signed data types and unsigned data types. Signed means where we can write both positive values and negative values. It can store both. Okay. In signed we have short int, long int, byte, integer. What is the difference between int and integer? Most common question in the interviews. What is the difference between int and integer?
Both will
Uh,
store
Two
32.
state and four state.
yes,
Okay,
two
which
state
is
and
a
four
two
state.
state and which is a two state and which one is four state?
Int is
Int
a
is
two
two
state,
state, integer four
integer
state.
Mm-hmm.
four state.
Okay, int is a two state. That means it can store only 0 or 1. Whereas integer is a four state. It can store 0, 1, x, z. These two are not useful. So these two are neglected in SystemVerilog and got new data type called int in SystemVerilog. But in Verilog we don't have int, right? Okay, next what about the unsigned data types?
A byte, integer, reg,
Mm,
real, time. These are the
okay.
unsigned data types.
Okay.
Logic.
Byte is also signed. In unsigned, we have bit, reg, time, logic. So, what is the main importance of logic data type?
It can have four
Why do
values,
we?
0, 1, x, and z. And it
Okay.
supports for both the combinational and sequential and procedural assignments. Actually, in Verilog, for procedural assignments, LHS side we will use reg and RHS either reg or y, right? In order to avoid whether we have to use reg or y, in order to avoid confusion, SystemVerilog introduced logic data type. It supports for both procedural assignments and combinational logic.
Okay. So, if you remember everyone, in Verilog HDL, whenever we use declaration, input output declaration, must be declared with the reg data type, outputs must be declared with the var data type. Okay. So, why it is, can anyone tell? Why inputs must be declared with reg data type? Why outputs must be declared with var data type in Verilog?
To perform operations or to perform any arithmetic operations, so we need to store the inputs in some registers. So that's why we need to those inputs might be needed for further process. So that's why we store them in register. And while output, sometimes it needs to be given as an input to another block. So that's why it is going as it's driving as a wire.
Mm-hmm. Okay. Can anyone answer any other answers? Any other answers remaining?
Yeah, wire is just used for physical connection, and reg
Okay.
is for to store values.
Okay. Remaining Lavanya, Pragna, Pradeep, Sachin. Can you answer? Jarin. Jarin, are you there? Okay,
Yeah,
see. Basically, in Verilog HDL, we assign the input stimulus to the input variables. Okay, so where we write all those things in the initial block or in the always block. In within initial, we can put repeat or we can put forever or we can put some other for loop or whatever. Okay, now initial and always blocks are procedural assignment statements. Procedural assignment statements. So, for procedural assignment statements, what are the major rules we need to follow? LHS side variables must be declared with the reg data type. RHS variables can be declared with either reg or wire data type, right? Now inputs will work as a LHS here, A equal to some 10, B equal to 20, C is equal to 40. So these are sitting in a LHS side. So that's why LHS side variables must be declared with the reg data type in Verilog HDL. Okay. So whenever the complexity of input variables are increasing, that means whenever there are more thousands of variables, every time we cannot check what are the inputs, what are the outputs. It is very bit confusion. Okay. So that's why in SystemVerilog what happened? We just got the logic data type. We just got the logic data type where we can replace reg and wire data type. Okay. So now in interface, we declare the logic data type for input declarations or output declarations. Okay, everyone clear?
Yes.
Okay, next, what we write in interface? Only inputs and outputs, huh?
And mod ports, clocking blocks.
We write the clocking block and mod port. What is the difference between clocking block and mod port? Can anyone answer?
Mod port define direction and which are inputs and which are outputs. So clocking
Mhm.
blocks to provide synchronization between different components, we will use clocking blocks.
Okay, so everyone, if you observe here, we have a test bench architecture. Okay, the interface here is the interface is connected with the driver and monitor also connected with the interface. Through interface only the signals will send to the DUT. Okay, so to make the proper synchronization between driver to interface and monitor to interface to work properly, the driver and monitor, okay, in synchronization we are using the clocking block. Okay, so clocking block means we just declare as a clocking, end clocking, and we can write the skew also. What is mean by skew? Skew is nothing but at what time we need to do the sample. Okay, input sampling and output sampling. Based on that we can just give the extra delays as per the requirement. If you want to require like proper synchronization, you can do that. You can add the delays through the skew also here. Okay, and mod port is nothing but the port directions. If you see here, there is a driver. Okay, before that, let me explain the transaction class. Okay, after that we'll discuss the mod port. Okay, so can anyone tell what is the transaction class here? What is the transaction class? After writing the interface, mainly we need to write the transaction class here. Interface transaction. Transaction is a class or object? Can anyone tell? Is this
It's
class
a
or object?
it's a object.
Transaction is a class. Class
Oh, class. Okay.
transaction, class transaction. What we write exactly in the transaction?
All the variables,
Mm-hmm.
input,
Okay.
inputs, outputs,
Okay.
and
Suppose there is a address and there is a data and there is some write pointer and there is some read pointer and there are some control signals, whatever we write within the transaction class. Okay, now these must be declared, right? Address you can declare with as a bit or 8-bit address, something like that. Data also you can declare with a bit, 8-bit data or 9-bit data. Write pointer you can declare with a single bit data. This also single bit data. Okay, in Verilog HDL example, in Verilog HDL, if we want to assign some values within the initial block, I have written the initial block here, right? So here there is a initial and a equal to 10, b equal to something, c equal to something I have written. Okay, now I want to assign some values here. Suppose I want to randomize initial, begin. What we do? A equal to $random, b equal to $random, C equal to $random. Okay. Here it do the randomization according to your how much size assigned, either 3-bit size or 4-bit size or 5-bit size, we just assign. Okay. Suppose here 3 variables means we just declared A equal to $random, B equal to $random, C equal to $random. Okay. But if there are hundreds of variables or thousands of input variables, then how it is possible to write a $random, $random, $random to all? Hmm? It is not possible to write for all, right? So what we are doing here, we are using the randomization concept. Here we are using the randomization concept in SystemVerilog. Okay, randomization means it generates the random values and assign to the variables. Okay, suppose it's a 4-bit data, that means 3 down to 0, the address is 3 down to 0, that means within 0 to 15 any random value will be generated. Okay, within suppose it is a 32-bit data, within 2 power 32, 0 to 2 power 32, it just randomize any value and assign to the variable. Okay, but here in SystemVerilog, whatever the randomization we are using, that is not just like a $random. $random is a static in nature, but in SystemVerilog everything is a dynamic in nature because we are using the class and object. So here we have a special method, that's what we call as a randomize method. That's what we call as a randomize method. Okay, so by using this randomize method, single randomize method, we can access all these variables through object. Okay, every variable we need no need to put a randomize address, randomize data, randomize write pointer, randomize read pointer, no need to put, because we are accessing through object. I will tell you what is meant by object concept also. Okay, so whenever we are using randomize method, we need to declare these as a rand keyword, rand or rand c. Can you tell me what is the difference between rand and rand c?
Rand will
What is that?
generate a pseudo
Hmm.
random values. It may contain some repeated values. Rand C is like a cyclic manner. Once all the possible values covered, then only cycle repeats.
Okay, so rand keyword means it will may generate repeated values. Okay, because suppose a 3-bit variable is there, in 3-bit variable 0 to 15, that means 0 to 7, in 0 to 7 if I got a repeated value, example 2 4 3 2 6 7 4 2 again, so this is what the sequence I got. 2 is repeated 3 times, 4 is repeated 2 times. So instead of repeating the values, there are some uncovered values like 0, 1, 5, some these three are uncovered. Okay, you can cover these cases, right, without repeating the value. There is no use of repeating the value. Okay, so to avoid this problem, we are just putting as a rand c here. Rand c means it just repeat the sequence, one circular sequence, any random value within the range. Once the range is completed, that means all cases are covered, then it will repeat the same value if still there are number of transactions. Okay, so that is what the class transaction. Okay, not only this variable declaration, we write the constraints also. We will discuss the constraints also. What is meant by constraint? Can you tell me? What is mean by constraint?
Putting some conditions to the randomization.
Hmm?
Putting some conditions to the randomization.
Okay.
They can be said as rules to rules to define randomization.
Mm, rules to define randomization. Huh? Mm, okay. Okay, see. Suppose here there are a 32-bit value. Address is declared with the 32 bit. 32 bit means what? 2 power 0 to 2 power 32 values it will be generated. Any scenario, any corner case scenario it can generate. Okay. But in real time, suppose there is no requirement of generating 2 power 32 values for us, or else we have particular scenarios to verify some functionality. We need to verify particularly few scenarios to reach our feature or to reach our functionality goal. Okay, suppose for example there are four number of operations. Okay, there is a addition, subtraction, shift left, shift right. Example, suppose to do the addition I need to pass the command. Command is a 3-bit variable or 4-bit variable. Okay, to do the addition operation I need to pass a command 0. To do subtraction operation I need to pass a command 1. To do left shift I want to pass a command 6 or 5. To do right operation I need command 6. Okay, by using these commands only do the proper operation. I have only 4 operations in my design. Okay, suppose there are I have declared with the 4-bit, it may generate some unwanted cases also. Unwanted values like a 2 may generate, 3 may generate, 4 may generate, 7, 8, 9, 10, like that. So many corner cases, so many cases it can generate, but it is not useful for us. There is no requirement with that values, right? So whatever the required values are there, whatever we have the requirement of the value, if we generate proper that value, that means we are controlling our randomization. According to the requirement we are generating the values. So I can write the constraint, like I can use inside constraint or inline constraint. Particularly inside constraint means 0, 1, 5, 6. I can write like this. Okay, example, if you don't want 0, 1, 5, 6, other than this you want remaining all, suppose 2, 4, 2, 3, 4, 7, remaining all cases you want, then what you need to put, just inside not or not inside. Okay, so this is what the constraint. Constraint means controllability on the randomization. Like that, if I want to generate only odd values, 0, 1, 3, 5, 7, 9, 11, within the range 0 to 20, I need odd values. Or else within 0 to 20, I need only even values, 2, 4, 6, 8. Like that, there are lot of constraints like inside constraints, internal inline constraints, soft constraints. Okay, so that is what the concept of constraint. Did you understood everyone?
Yes.
Okay,
Yes.
now, so within the transaction class, what we need to write? Class transaction, we need to put the variable declaration. If there are any constraints, we can write the constraints, 2 constraints or 3 constraints, 10 constraints, according to your functionality, you can put any. Okay, and end transaction. If you want to put some display statement, you can put, or else no. End transaction. This is what the transaction class. Did you understood everyone?
Yes.
Any other doubts still here? Hello. Okay. Next, where is our test bench? Okay. Now see here. So transaction class we have completed. Now in our transaction class, all the input variables are declared. Okay. Now what we need to write? Next one is a generator block. Okay, whenever you are designing some test bench, system verilog test bench for a design, you need to follow this proper flow. Okay, you should not start with the generator first or monitor first or environment. Sorry, this is environment, not transaction. Environment, like that you need not to follow. Okay, so now I need to create the generate block. Generator means, what is mean by generator? What is mean by generator? Hello.
It will generate the randomized
Yes, ma'am.
stimulus based on the transaction class.
Mm. It will generate the
It
random
generates
stimulus.
multiple inputs or required inputs for the uh, like it basically generates multiple inputs, ma'am.
Mm. Okay. Okay. So main other some main concept is there here. What is that concept? Did you remember? Hmm?
Mailbox.
Okay. What is meant by mailbox?
It is like a communication mechanism between two components to send and receive data
Mm-hmm.
between components. Here we will
Okay.
use like a put method, get method,
Okay. Why
or if it
particularly we use mailbox here? Why not queue or array?
uh, suppose let us consider two components. Those two like generator and driver both are working at a different speed. Um, a generator operate at one particular speed and a driver will may take some time to receive those values. So in order to avoid data loss, we will use mailbox. It's like a component to component communication, whereas like queue is like a one to many. For data manipulation purpose we will use queues. There
Okay.
we will use, yeah.
Mm. Okay. So everyone understood what she told? Okay, see, suppose here, what is mean by generator? What is mean by generator here? Generator is nothing but just now we have written the transaction class transaction. In transaction, what we declared? Address, data, write pointer, read pointer. These variables we have declared. Okay. Now we declared with rand also. That means because these are ready to randomize. Okay, if you want to randomize, you need to declare those variables with rand. Outputs no need to declare because we don't randomize outputs. We randomize only inputs, right? So all these variables we kept in one bundle. Now suppose transaction we kept in one bundle. Okay, so this transaction is a class now. Can anyone tell what is the difference between class and object? What is the difference between class and object?
Object is like a blueprint of entire class.
Hmm.
Means
Okay.
basically class we can say that it describes uh, it is kind of description and object is kind of instance of it.
Mm-hmm. Okay. Any
Class
other
has
one?
different kinds of like it has different or multiple kinds of objects, and object is any one in particular. For example, if we take a class of students itself, so different each student has a different name, so each student represents an object, but all the students put together in one section is called a class.
Mm.
Yeah,
Okay.
class contain properties and methods. The instance of a class is nothing but object.
Mm. Okay. Okay. Good. So class is nothing but it consists of some properties. Properties means functions, task. It contains some members or sequence items or transactors. Transactors are nothing but the variables. Okay. So everything, the functionality, the main functionality. So, whatever we declare within the class or whatever the functionality we put within the class, that thing, task or functions or members, everything we can access through object. That's what we call as a instance. That's what we call as a instance. Through the instance, we can access the uh, variables or properties of the class. Okay, did you understood everyone?
Yes.
Now, Now, if you see here, these are the transaction. In transaction, there is address, data, write, read. Okay, all I kept in one bundle. Now I am writing a generator class. Class generator. Now in generator, what we need to do? We need to do the randomization of addresser, data, writer, read. Okay. Before I already told you in Verilog HDL, if you want to randomize the variables, we need to put individually $random, address equal to $random, data equal to $random, write equal to $random. But in SystemVerilog, because of the object-oriented programming, because of the class-based verification, we just create an instance and we can access everything just using a object. Okay. Now what I am doing here, I am creating a object of the transaction class here. Okay. So transaction class name of the class is transaction. I am just creating a object tr. Okay. Now here this tr is a object or instance. Okay. By using this object or instance, now I am able to access address, data, writer, reader, everything. Okay. So tr equal to new. This is how we create in SystemVerilog by using the new method. Now what I am doing, I need to do the randomization of all these variables. So simply I am just calling all those variables through tr dot randomize. tr.randomize. So what we do, this tr directly will connect to the class transaction. So whatever the variables are there within the class, address, data, write, read, everything. Suppose there are outputs, output something. This output is not declared with the rand keyword, so it doesn't do the randomization. Whatever declared with the rand keyword, those will do the randomization by using tr.randomize. Okay, everyone understood?
Yes.
Now we did the randomization using transaction class. So generator means doing the randomization and sending to the driver. We need to send to the driver. Okay. But what is this mailbox in middle? What is this mailbox in middle means? For example, here generator, I'm generating 10 these are what the transactions, right? These address, data, all these are transactions. Okay. So here I am generating 10 number of transactions. In what time? Just in 10 seconds I am generating 10 number of transactions. Okay. All these 10 transactions need to send to the driver. In driver also should receive all those 10 transactions in same time, in 10 seconds, right? But here what happening? The driver is sending the data to DUT via interface, right? So that means here we are getting the packets. We are storing the data into the packets in driver. That packet data is converting into the pin level data in a DUT side. Okay. While converting the packet level data to pin level data, we have some time requirement. It takes some time. Immediately it cannot send. Immediately it cannot convert. Okay. It takes some time to complete the functionality. Did you got my point, everyone?
Yes.
Okay. So now 10 transactions, it cannot complete in 10 seconds. Okay. It may complete in 10 seconds. It may complete only 4 transactions or 5 transactions. Only 4 example. Okay. Now what happened? Next to 10 seconds. In next to 10 seconds, generator again sending 10 transactions in next to 10 seconds. Okay. Now what will happen? The driver will again connect with these 10 test cases or 10 transactions. Whatever it is doing currently, it will left that. It will just leave that and it will connect with these 10 transactions because new transaction is initiated. It just need to follow up with the master signals or transmitter signal. So it just continue with the new 10 transactions. Then what happened? Before it just completed only 4 transactions, still 6 transactions are there. So what happened for these 6 transactions?
It's temporarily stored in the mailbox.
Here I didn't use the mailbox. Without using the mailbox, I am asking. without using mailbox? Anyone answer? Anyone can answer?
Can you please repeat the question once?
Now, those 6 transactions, what happened? That's what my question. Because here, within 10 transactions, within 10 seconds, it not able to complete all the 10 transactions, able to complete only 4 transactions. Now, generator again initiated 10 transactions in next cycle or whatever. Now, a driver is going with this 10 transaction. It is already started. So what happened for number before 6 transactions?
The transactions will be lost.
If no mailbox, then loss of information or transactions would be lost.
Okay, so the data loss will be happen here. The transaction will be going to loss. Okay, but in real case, whatever the number of transactions are generated by generator, all the transactions need to send to the driver properly, because we should not lose anything, any transaction. If the transactions are lost, means our verification is not going to be 100%. We are not driving all the test cases, right? So for that purpose, what we are doing here, we are simply putting a mailbox, which is a temporary storage like a FIFO. Okay, so it have n number of data, n number of locations. It is like a first in first out. What is the first in first out functionality?
The
The way
data
we
or
store.
the first one entering will be coming out as an output first.
Okay, so first transaction is sitting in 0th location, second, third, fourth, fifth, sixth, seventh. Okay, so first in first out retrieving. So a driver is required with the 0 transaction. So it comes to the driver and it performs the task and it will send to the DUT. And then first one, and then second one, and then third one, and then fourth one. One by one, it is going to give to the driver. Driver is accessing. So here, what methods we use in the mailbox, in the generator side and also in driver side for
Put
mailbox?
method, get method.
Get and
Mm.
put methods.
Put method is used to store the data into mailbox. Get method is to get the data from the mailbox to the driver, right?
Yes.
And also in mailbox we have non-blocking, which are try, put, try, get.
Try
What
get.
is the difference between try, put, try, get and put, get?
Try put is like if driver is not ready,
Mm-hmm.
it doesn't wait. If it is send acknowledge, if returns one, if the space is available. If it is not, space is not available, means it returns simply 0.
Okay, it doesn't wait for the next one
Yeah.
or until it get the space. That's what the non-blocking. Whereas a blocking means it wait until the
Spaces.
next transaction should get. Okay, so that is what the blocking. So mostly we use the put and get methods only, which are blocking. Okay, so now this is what the mailbox concept, where it stored the data temporarily. Okay, but instead of mailbox, we have something like queue. Queue is also, it have number of locations, and something like array, it stores some data, or queue. But why don't we use these? Why do we use only mailbox?
Mailbox is like component to component.
Hmm.
It will use. The queues
Okay.
are like just for the data manipulation. One to many, we can store as many as based on the
Okay.
size.
Remaining,
There we
any
will use
answers?
push underscore front method, and push underscore back, deletion, addition.
Hmm.
We will use
Actually,
methods.
in in arrays, like we are going to store it based on the index number or the element. So like if we are having many number of transactions, the array size also will become more. So which the transactions might, I mean transaction in the sense the data which is entering and exiting with the concept of like from the mailbox, it might take time. So time consumption. And like if the base the two things is size and time consumption.
Okay. Okay, so array is basically it's a single data array, single data only. Any data type we can store, and also as you said, it has fixed element size, which is within the class we can write, not outside the component to component connection. Whereas a queue also same. Within the class we can push the data and pop the data. That means we can store the data and retrieve the data. But whenever you are connecting component to component outside the two classes, the queue is not going to work. Only mailbox will work in this case. Okay, everyone understood? What is mean by mailbox here? Mailbox is mainly for synchronization between generator and driver. Is it clear?
Yes. Yeah.
Yes, ma'am.
Yes.
Okay, now okay. So now we are going to call the transaction. We already randomized the transaction data. Now this transaction data we are putting into the mailbox by using the put method. So here we are using the put method to put the data into mailbox. So for that purpose, first of all, here we need to declare some mailbox gen2 driver gen2 drive. So we have declared as a gen2 drive. Now by using this gen2 drive gen to drive put dot put of tr. So we are putting this transaction data into the mailbox gen to drive. So this is how we need to write the generator. If you want to write something more like any display statements like that, or if else some randomization failure statements like that, you can write. But general code is this is how we can put. Did you understood everyone? The generator class. Hmm? Okay, generator completed. Now driver. What is mean by driver? What is mean by driver? Hello.
It's a
It will drive
component
signals
which
to
has
the
to.
Tell.
it will drive signals to the DUT through the interface.
Okay. So driver is also a class. We need to write the class driver, and for driver we need to create the not only for driver, any class we need to create the memory to the class. How can we create the memory to the class? How can we create the memory to the class? By using function new constructor. Did you remember? We need to pass the connections. For driver, how many connections will be there? And for generator, how many connections will be there? You just see here. For generator, only mailbox connection is there. So while writing the generator code here, we need to pass function new only mailbox instance. But for driver, we have mailbox connection and the interface
Interface.
connection. Okay, so here we need to write the mailbox connection and also interface connection. Okay, now here we got the concept of interface. See here, interface means this interface is a static in nature. Normally we just created. Here if you see, interface is just like a normal like module name, which is a static in nature. But this interface is going to connect with the class driver or class monitor. So class driver and monitor are dynamic in nature. These functionality is dynamic. Is it possible to connect a static environment with a dynamic environment?
No, ma'am, we have to use interface, virtual interface.
Hmm. So to connect the driver dynamic environment to DUT dynamic environment, we are creating this interface as a virtual. That's what we do in the driver. Now, by using that virtual interface, we can access the DUT or the driver. So, to that to that interface, we need to create the virtual interface VIF example. Okay. Now, using this VIF, we can access any variables of DUT. Did you got my point, everyone?
Yes.
And also, here the driver is connected with the mailbox and getting the data from the mailbox, which already we put in the mailbox. We need to get the data to the driver. So how we need to get the data from the driver here? First of all, we need to create the mailbox with the same name, whatever you used in generator. So so now in main task, you can get the data of mailbox, get of tr, which is from mailbox. And now after getting this data from transaction, you need to put into the DUT via virtual interface, right? Whatever we got here, address, data, write pointer, read pointer, all this data we send to the DUT random data using virtual interface. Okay. So what is the instance of virtual interface? VIF. VIF dot address is equal to tr dot address. First of all, you need to do the reset initialization. Then you can send all this data. VIF dot data, VIF dot write pointer, read pointer, everything you need to send from tr dot data, tr dot write pointer, tr dot read pointer. Okay, this is what the main driver logic. Understood, everyone?
Yeah.
Okay. And next thing is, I told you to remember some point here. See, in interface, we have written the clocking block, right? Clocking block and also mode port. What exactly we need to write in the clocking block of interface? As I told here. Here I written, but I didn't explain. What exactly we need to put in the clocking block and mod port?
In mod ports, we have to declare the define the direction.
Hmm.
Inputs
Mm.
inputs as outputs and output as inputs, and then we have to use like VIF dot clocking block dot data, like that we have to use.
Okay. So what we need to do means here we have connected virtual interface. Okay. An interface, there is a clocking block. I already told you clocking block means it's a synchronization between mod port and the synchronization between driver and the DUT. Okay. In clocking block, we need to mention all the inputs and outputs. Okay. But if you see here, for driver, the actual inputs will work as the outputs. Suppose in the design, you have declared some inputs. These all are inputs. Okay. Inputs are something, address, data, write pointer, read pointer. These are inputs. Okay. For design, outputs are read data, some ready signal, whatever, some error signal. These are outputs. Okay. But for driver, how these are getting inputs will work as an output. That means inputs are randomized by generator. Those are getting out of the generator and sending to the DUT, which are getting out of the driver. Okay. So these inputs must be declared as a outputs in driver. Outputs in driver. These outputs must be declared as a inputs in a driver. Did you understood my point, everyone? Hmm? Did you understood?
Yes.
Tomorrow we are going to discuss whole test bench architecture, right? Then you will get the clarity how what I am telling the theory. Okay. I think you already learned SystemVerilog. I think you already know all the concepts. So now in the monitor, see in the monitor, whatever the data we are sending to the driver, whether it is input or output, all the data is getting out of the DUT. Out of the DUT. That means inputs to the monitor. Inputs to the monitor. So that is why in clocking block, in monitor clocking block, all inputs or outputs must be declared with the inputs. Must be declared with the inputs. Okay. And same as mod port. Mod port also. We just declare all the inputs and outputs. Driver mod port and monitor mod port. Did you understood, everyone? Hello.
Yes.
Okay. So till now, just up to driver is completed. Now driver is send the data to the DUT. DUT will do some functionality according to your RTL design code, and it generates some output. That output is sent to the monitor. That output is sent to the monitor. Now again process is repeated. Monitor to mailbox by using put method. Mailbox to scoreboard by using get method. Okay. Can anyone tell what is mean by scoreboard? What is mean by scoreboard?
A scoreboard it's like a component which already has predefined or expected output. So when the monitor receives the output back, it will send it to the scoreboard, and scoreboard compares if the received output and the expected output is true or not, and then it gives the it gives the summary, or it gives the analysis of that.
Mm. Okay.
And
Next.
it even shows how many when it comes to the coverage, it shows how many bins are being hit, and how many times does the bin has been hit if with a particular value or something.
Okay. Okay. So scoreboard is nothing but it just compare the actual output with the expected output. So in Verilog HCL, basically what we do, we write the test bench one side, and whatever the output we got in log file, some output, that's what the actual output we got. Actual output we got. But we cannot write any logic to check that, to compare the actual output with the expected output. We just need to write the theoretical calculations. You already know how to do in our laboratory, right? In the same process we do in a Verilog HDL. But in system Verilog, what we have? We have a scoreboard logic. Scoreboard means we do write the logic for logic to check the expected value and compare with the actual value. Okay. So whenever the actual value is equal to expected value, which is getting from the result, expected value, then we can write our test is pass. We can write our test is pass. Whenever test is that both are not correct, it represents test is fail. That is what the scoreboard. Did you understood everyone?
Yes.
Okay. Next. Now, whatever the both four we have discussed, one is a generator, one is a driver, one is monitor, one is a scoreboard. Now where we will run these four, because in generator we have written main task, which is randomization. In driver we have written main task, which is send the data to the DUT. Monitor also we have written main task, and scoreboard also we have written main task. So from where all the four tasks will be called?
In environment,
Okay, so in the environment is the top level where we write the instances of all these classes and we do call. Okay, what is the top level of environment?
test,
Test.sv, where we can connect with the DUT. And also in tester, do we use module block or program block? What is the difference between module block and program block?
elements within program block will execute in a reactive region, so it will avoid the race condition between
Hmm.
test bench and DUT.
Okay. Okay. So, yeah, program block is used to avoid the race conditions between test bench and DUT. Normally, in Verilog HDL, there is a test.sv or test.v, and there is a design. We connect both using the module. Okay, but in system Verilog we have a reactive region where the module block will execute and get the race conditions. To avoid these race conditions, we are using the program block, which is the same as a module. Just it avoid the race conditions. Okay, that's what program block in system Verilog, and that too we use in the test.sv. Did you understood everyone? Hello. Now, for test.sp, what is the top module?
Test bench,
Testbench is the top module.
Testbench.sv. What we written in the testbench.sv? Hmm? We generate the clock. How can we generate the clock in Verilog HDL? Can anyone tell? Very basic question. How many ways we can generate the
With the
clock?
help of initial begin blocks,
Mm.
we
Okay.
can
always, forever, repeat,
yeah.
Mm. Okay.
clock equal to not
So
of
always initially we need to mention initial clock equal to 0. Always #5 clock equal to not
not of
clock. To stop a simulation or to terminate the simulation, what we can write?
dollar finish
Dollar
or
finish.
dollar stop.
Dollar finish or dollar stop? What is the main difference between dollar finish and dollar stop?
Dollar finish just finishes the simulation, but dollar stop completely it closes the app or the simulation itself.
No.
It will suspend.
Dollar finish will permanently terminate the loop, terminate the execution. But dollar stop, it just pause the execution. Just stop or pause the execution, and after again if you run, it just do the simulation. Okay. What is the main difference between always and the forever loop and the repeat? Most important question. Always, forever, and repeat. Hmm?
Always will execute continuously. Repeat means certain times, like a repeat of 5, a repeat of 10. Based on that, it will.
Mm,
Always actually based on the sensitivity list, it will trigger. Then repeat, it is like fixed number means and forever it is like infinitely inside a procedural block, it will continue to repeat itself.
always is also a continuous loop, right?
Yes, but based on sensitivity.
Okay, but in Testbench we don't mention the sensitivity list.
Yes.
Then what is the difference? Remaining Jarin, what is the result? What is the difference? See, always and forever are repeated continuous loops. Always and forever are continuous loops, whereas a repeat means a fixed time, just a 10 number of times or 100 number of times or 20 number of times, whatever the limit you kept. But always is a always is a synthesizable. That means you can use in the design, you can use in the design plus test bench. But forever is non-synthesizable, you can use only in the test bench. Okay, that's what you need to tell. Okay, next our system Verilog architecture is completed. Any other doubts? Hmm? Next question. What are the difference between logic range completed, int integer completed, packed and unpacked array? Can anyone tell what is the difference between packed and unpacked array?
If we declare dimensions before the variable, that is a packed array. In packed array, memory allocation is like a continuous in nature.
Mhm.
In unpacked array, dimensions declared after the variable, memory allocation is like a non-contiguous.
Okay. Remaining any answers? Any answers? No? Okay, next question. Sixth one, static dynamic associative completed. Semaphore mailbox. I will explain semaphore. And interface, virtual interface completed, class object completed. Okay, next inheritance and encapsulation. Okay, so packed array, unpacked array means both will get in a static array declaration. What is mean by static array declaration? In SystemVerilog, we have static array, dynamic array, and associative array. Static array
Fixed.
means fixed size.
Fixed.
Once it is declared, we cannot change the value. In static array, we have single dimension array, multi-dimensional array. Okay, single dimensional array means what? Suppose array 3 bit, 3 down to 0. We can write right side, or else we can write left side of the name also. Okay, if it is a multi-dimensional, two-dimensional means it have some 3 down to 0, 7 down to 0, right side. You can write the left side also, left side declaration array, 2-bit size. If it is a three-dimensional, you can write the right side and left side also. Left side also 2 down to 0, 3 down to 0, 1 down to 0, like that. So in one dimensional means it has only either rows or columns. Two dimensional means it have rows and columns. Three dimensional means it have rows, columns and pages. Okay, I think you already know what is mean by row, column, pages. If we write like this, it is row. If we write like this, if it is a column. And if you want pages means this is one page, page 1. Same if you create something other, page 2, page 3, like that. Third dimension indicates the pages, page 1, page 2, page 3. Okay, so in this type of declaration we have packed, unpacked. Okay, see here, same. Suppose here packed means what? Before array name, if you declare this is packed. If you declare after the name of the array, it is unpacked. Packed, unpacked. Did you remember everyone? Here
Yes.
rows, columns, pages, like that. Okay. Everyone clear till here? Now, if you see the memory, it packed and unpacked and packed means nothing but how it is loosely coupled or tightly coupled, or there will be a gap within the memory it will store, or the structure is different. Okay, suppose I am writing bit. Suppose I am writing bit array, any dimensions like 1 down to 2, or something 1 down to 4, or 1 down to 3, or 0 down to 3, something. Okay, now what happens here? This 2 will be the pages, number of pages. This will be 1 down to 4 will be the number of rows. Okay, or number of columns. Number of columns. Here number of rows. Okay, is this packed or unpacked? Is
Unpacked.
this unpacked? Because after the name of the array we have written, so that's why that is unpacked. The dimensions are written after the name. If the dimensions are written before the name, that is packed like this. Okay, so this is unpacked. Unpacked means how the structure will look like the array. 2 pages, right? 2 pages means this one, page 1. Page 1 no page 2, page 1 no page 2. In page 1 how many columns, how many rows? 4 columns and 3 rows. 4 columns, this one will be the rows, this one will be the columns. So 4 rows, row 1, okay, 4 4 1 2 3 3 rows, okay, before whatever I written it's correct. That is what the confusion here. This is columns, this is rows, okay. Like this page, 2 pages, this is page 1, this is page 1, same we will have page 2 which is unpacked. The memory is like this, separately, 4 rows, 3 rows, 4 columns, 3 rows, 4 columns. Did you understood? Hello.
Yes, ma'am.
Yes.
Same I am writing with the unpacked, okay. Bit 0 to 3, 0 to 2, 0 to 4, whatever array. Now what happened? 2 rows or 3 pages, everything like this. Page 1, no? Because 3 I have written left. Sometimes you can write 2 left, 3 1 right, 1 right. If it is a pages, then page 1, page 2 will separate. Remaining columns and rows will be tightly within the memory. Okay. Or if you write this also left side, all are combined. This is page 1, in this only page 2, and rows of columns. Did you understood?
Is the format always the same? Page,
Yes.
rows, and columns?
Yes. Okay. Next, semaphore and mailbox. What is the difference between semaphore and mailbox? What is the difference between semaphore and mailbox?
Semaphore is also like a synchronization object mainly used to control shared resources between different processes. Here we will use keys to
Okay.
for object key creation. We will use like a new method. Argument to a key will define how many keys are available.
Mm. Any other answers remaining?
Semaphores act or use this master slave concept, and yes, ma'am.
Yeah, tell.
I know only that much, ma'am.
Semaphore. What is mean by semaphore? Hmm?
Ma'am, I just know that they use the concept of master and slave.
Okay. Okay, see. Mailbox you already know. Semaphore means, suppose it's a number of tasks. There are suppose like there are task 1, task 2, task 3, task 4. Okay. All are written in a fork join. Fork join means what? What
It's
is
like a
mean by
parallel
fork join?
execution. Parallel execution.
Okay, it's a parallel execution based on the delays. Less simulation delay will execute first, and then the highest delays will execute accordingly. So here, based on the priority, the task can execute based on the priority. So first third task need to execute. Maybe it have less delay or high delay. That's not a matter. The third task has a highest priority. Okay, now here we use the semaphore concept. In semaphore we use a key concept. What is the key? Key means it is giving the permission, it is giving the access to do some task. Okay, example, simple example, there is a car, there is some car, there are four persons need to access this car. Okay, so person 1 want to go some direction, person 2, person 3, person 4, four members, four directions. Okay, but four members need the key, there is only one car key, right? Four members want the key, but how they access that key? They access based on the mutual understanding between these persons. Okay, so mutual understanding means they just discuss which task can be performed first based on the priority or whatever. Okay, suppose person 1 is going to some tour which is 2 days or 3 days or long delay, highest delay. Okay, some person 2 is going to some emergency for some hospital or whatever, some emergency. Okay, person 3 is going to some market which takes some time for market, and person 4 is going to some relative homes like that. Okay, for some reason, and can get back within 1 hour like that. Okay, now based on the mutual understanding, who will take the key first here? Based on the mutual understanding, who will take the key first?
Who have the emergency?
So whoever have the emergency, P2 will take the key first. They do some task with the car, they just take the car and they do some task and they will return the key back. Okay, now P1, P2, P3, based on this mutual discussion, if P3 is going to market which is a less delay, just within 10 minutes or 15 minutes they can complete the task because P1 is going to some tour or whatever. So P3 can access the key, car key now, and it do it task because it just a small task. Okay, now P3 will access the key. Semaphore also, there are methods, put method and get method.
Yeah, same. Put and
Put and get.
yeah, put and get.
So they will P3 will take the key, do the task and put the get the key and put the key in mailbox, put the data, get the data, right? But in semaphore, get the key, put the key. Okay, so now P3 will get the key, do the task and put back to the car. Now car is free to access, that means key is available to access. Now based on P1 and P4 mutual understanding, anyone can take the key, access the key, do the task and back the key. And then last task, last person will do the will access the key. Same semaphore concepts also same. Just syntax you need to remember. You just need to create the key with a sema of 1 or 2 or 3. 1 means 1 key, 2 means 2 key, 4 means 4 keys. Like that. Syntax you need to follow. Did you understood?
Yes, ma'am.
Okay, next concept. What is the difference between inheritance, encapsulation and polymorphism abstract class? We need to complete fast. Still UVM out there.
Yeah, inheritance is one of the concept in OOPs which allows to create uh, existing data type.
Okay.
external class from the existing class. The external class is called derived class or child class. Existing class is nothing but parent class. It will allows reusability. Child class can access the properties and methods of base class. Along with the existing properties and methods, child class can also add new properties and methods based on the requirement. That's about inheritance.
Okay.
And encapsulation is a data hiding mechanism to hide class members within the class, and they are not accessible from outside of the class. By default in SystemVerilog, all the properties and methods we can accessible through the instance. So in order to provide restriction, we will use a class access qualifiers are useful. Local and protect. In local means we can access only within the class. They are not accessible outside of the class members.
Okay.
In protected means we can access within the class and its subclass. The encapsulation mainly used for data protection, and only we can hide the internal details and expose what's are necessary. That's
Okay.
about encapsulation.
Mm. Any other answers remaining? Okay. So inheritance means in system verilog basically we can write a class. The parent class can be accessed by the child class. Suppose there is a cla class which is a generator. This is the main test case you are creating. Here you are creating one test case, test one, where you are randomizing the data using some constraints. Okay. Now you want to create one more test case. I want to create one more test case too. Directly you no need to again do the call the transaction data, do the randomization, create the class constructor, because here we create the class new constructor, that means function new constructor. Before I have shown everything, you no need to write, because parent child class can access the parent class properties, but parent class cannot access the child class properties. That's what the inheritance means, just driving the child class from the parent class. Okay. So from for this class, now I am creating the parent class for test2 class. Test2 extends from generator, extends from generator. Now this test2 have different constraints which is related to the different functionality. Test case 2 and do the randomization. That is what test case 2. Again you want to derive some test case 3 from extends from generator or generator or tester. If you extends from generator, then it will be generator to generator to test 1, test 2, test 1, test 2. Here we will get the polymorphism concept. Whenever you are doing generator to test 1, test 1 to test 2, test 2 to test 3, then it will be the inheritance concept. There is a difference between polymorphism concept and inheritance concept. Okay. Tomorrow I will explain you clearly what is the difference. Okay. Whenever we write the, even in AXI protocol, we are going to develop the VIP, right? For test cases, different features. There I will explain you clearly the difference. Okay. And encapsulation. What is meant by encapsulation? Encapsulation is nothing but hiding the data. In encapsulation, what are the main we have to hide the data? We have local and protector. What is the difference between local and protector? What is the difference between local and protect? Hmm?
If we declare variables as local, only within the class we can able to access. We cannot access from outside of the class. If we declared
Okay.
variables or methods as a protected means, we can access within the class and its subclass.
Okay. See, local means suppose there is a parent class. Okay, there are some properties in parent properties, like there is some document related, some any land or whatever, some document related. There is some document here. In document there is a address, there is some ID card, ID something, there is some PAN number, like that, and there is some signature. Okay, now what is meant by child class? Child class can access the properties of parent class, but parent class cannot access the properties of child class. That's what the inheritance. Okay, now local means, basically these data cannot be accessed even by child and outside the scope. Outside the scope means outside the class, that means module. Within the module also the data cannot be accessed. Okay, local means child cannot access, module also cannot access the data. Access means what? You don't get the access to change this address, PAN number, signature, ID card, like that. That is safely protected. Okay, hide it. But whereas a protect means whatever the variables you declared with protect, those variables can be accessed by child, but not outside the scope. Can be accessed by child. Did you understood everyone?
Yes.
Yes, ma'am.
Okay. In Java we have public also, where child and outside the scope can access, but in SystemVerilog we don't have the public. Okay. Next concept is polymorphism. As I told, polymorphism is one to many, but polymorphism means where parent class can access the child class data by using virtual. It can override the data, and it can create some child class and assign the data to parent class, where the parent class is accessing child class by writing the virtual keyword. These all different concepts we have. I will explain you while writing the code. And next, virtual, pure virtual. What is the difference? Virtual, pure virtual.
Yeah, virtual concept is comes in polymorphism. Their child object can be assigned to the parent class handle. A method name should be same in both the child class and parent class. So override will happen. Uh, we have to declare virtual keyword in front of the base class method. Pure virtual means it's like just a prototype. Only body will be declaration will be there, and actual implementation will leave it to its subclasses.
Okay. What is randomization in system Verilog completed? RANC completed. Soft constraint, inline constraint. Anyone know? Did anyone? Soft constraint, inline constraint.
Yeah, when there is a conflict
Other
in
than
constraint,
Jivita, everyone, what about remaining? Have you not prepared? Have you not prepared remaining? Hmm? What about remaining? Okay. What is the soft constraint and inline constraint?
when there is a conflict in constraints, like for example, in within class, we will write constraint like address is greater than 5, and during randomization call with keyword, um, address is less than 5. So solver cannot solve because the constraints have a conflict. So in order to avoid, we will use the soft keyword. Um, soft keyword is like a weaker constraint, so override will happen. Soft constraint will ignore, then hard constraint will take the priority.
Okay. So soft constraint basically, okay, before soft constraint, what is the inline constraint? When we use randomize method, here only with the keyword we use constraint. Using with the keyword, we write the constraint. Whenever you want to override this, or else whenever, simple example, I will tell you. Suppose there is a transaction class. Transaction class. Here we write the main constraints, right? For overall feature or overall functionality, we write the main constraint. This transaction data we are going to randomize in the generator block. In the generator block. Here, while writing the randomize method in generator block, we can put with. Okay. So what, suppose here for address, we are generating the constraint for 0 to 100. 0 to 100. Okay. Whenever you want to override this and want to generate only 10 value for address, then you will write the inline constraint. You can write the inline constraint. Then what about the soft constraint? Hmm?
If there is a conflict between two constraints,
Hmm.
so
Then
one will
soft
be ignored.
constraint will soft
Yes.
constraint will execute. Huh?
No, soft constraint will ignored and hard
And
constraints
this
will
constraint will be
execute.
executed. Okay. When there are multiple, suppose this is one constraint, this is second constraint, then this inline constraint will be executed. Okay, understood everyone. You need to practice. Okay, if you have time, you just do the practice today. Then only you can able to understand. Next question is constraints. This. Okay, when someone can conclude the verification is 100% done as a functional verification engineers, you know already we are the functional verification engineers, right? So when can we conclude our verification is 100% done? Hmm? Hello.
Yeah, based on
When
first we have to thoroughly study the specifications. Once we understand the specifications, we have to write the test bench. If all the corner cases uh, is passed means
Mhm.
uh, like first we need to design the model. So design in the sense based on the specifications, as Jeevita also told, number of inputs and functionality, and then we have to check if the expected output and the received output is matching, and then we have to check for the coverage. So if the coverage also is giving 100%, then the complete verification is being completed.
Okay. Any other answers, boys?
To add one more point, we can also have regression stability. Like based on the regressions, we should not have bug identified. Means basically in the regression test, bug should not be identified.
Okay. Okay. So first of all, if you consider a IP or SOC level, there is a design and there are some thousands of test cases. 1,000 test cases. So do we write the coverage for design file or test bench file?
test bench file.
Is that correct? Hmm? What is meant by coverage? A single line definition. Can you tell in single line?
Yeah, it is like a user-defined metrics used to measure how much of the design functionality has been verified.
Hmm. How much design functionality has been verified? Okay. How much test cases are verified? You are not observing for test cases. You are doing for design. How much design functionality has verified? So then, do you write for design or test bench?
For the design.
For the design.
Basically, yes, we are testing behavior of design only. So for design,
So for the design, we write the coverage. And that coverage file can be included in the test bench also. Coverage.sv file you can write. Okay. Simply, suppose here there are 1000 test cases. As Jivita told, suppose if you write for test case, if you write the coverage for test case, what happened? Suppose example, for a design, the actual test cases are 1000, but you have missed 50 test cases and you have written 950 only. You have written 950 test cases only, and you are thinking you have written and covered all 100% test cases you have covered. Okay. Now this, if you write the coverage for these test cases, whatever the test cases you have written, only further the coverage will report will generate. So in that case 100% report will generate. It doesn't give what design functionality is not covered. Correct. But if you write the coverage for design, even the test cases, whatever the 50 test cases you have missed, that test cases will not hit at the coverage because the design is not covered in the test case. That functionality will not hit in the coverage and do not give 100% coverage, and it will stuck at 80% or some 70%. Did you understood? Now you need to understand what functionality, particularly what bins or what vector. Suppose it is a 32-bit, means 31 down to 0 address. So here we will write the bins. You can divide into any number of bins. You can divide with 8 bins, 16 bits, 32 bins, whatever. So you have missed 50 test cases, right? So maybe you have missed between 29 to 31. Okay, remaining 0 to 28, you return the test cases and coverage is hit here. Coverage is hit. So it will generate the 70% here. So whatever the not hit is there, you need to check what tests those are. So here 29 to 31 are not hitted. Even you didn't return the test cases for that. Sometimes even you hit the even you write the test case. If test case is failed, in that case also the coverage will not hit. Whenever the test is passed, for that only the coverage will hit the bins. Okay. So now here you need to check these tests and need to write the test cases and need to upload the coverage and extract the coverage and check the report. Here you will get the 100% coverage, not straight away. There are a lot of litigations also here. Okay, that's what the coverage bins and all. Okay, for APB we write the coverage and check. Did you understood? Actually, coverage have lots of concept like functional coverage, cross coverage, code coverage, toggle coverage. Even in functional coverage, there are transition of bin, sequence of transitions, multiple transitions. Okay, next question. Did you understood everyone what is meant by coverage? If you don't understand, I
Yes, ma'am.
already shared in YouTube. Nearly it is 1.5 hour session is there only on coverage, just on basic theory. You just go and check there. Next, yeah, what engineer get to know verification is done after functional verification. Okay, just check with the coverage, illegal bins, ignore bins, assertions. What is meant by assertion in SystemVerilog?
Assertions mainly used to check the design behavior. It will automatically monitor the design and it will report the violations. It
Okay.
will exactly pinpoint the cycle when a failure occurs. It will reduce the debugging time.
Okay. It just validate the behavior of a design. Suppose example, there is a clock cycle. Every clock cycle, what is the output? It will check for every positive edge of the clock or negative edge of the clock at point to point testing level. We write the assertions. Okay. Next, UVM test bench architecture. UVM. So, what are the major limitations of system Verilog and why we are moving to UVM? So almost the system Verilog concepts are covered, right? From basic to till coverage assertion.
Yes, ma'am.
Okay. So what is mean by UVM and UVM test bench architecture? We will conclude in 10 minutes. When we start a UVM test bench in next 2 to 3 weeks, then again we'll discuss all the concepts of UVM. Okay.
Um, Actually, System Verilog is a powerful hardware description that combines Verilog and object-oriented concepts. It provides a robust environment for verification, but it lacks a standardized methodology in scalable and reusable manner. That's where UVM comes into picture. UVM is like a framework that built on top of System Verilog that provides standardized methodology in reusable and scalable manner. It provides reusability. Suppose once if we write test bench for components like driver and monitor, we can reuse the same environment across different projects. This will provide the uniformity between teams, and also it provides a modularity. We can divide the entire test bench into smaller components like driver, monitor, scoreboard. Driver will drive the signals to the DUT. Monitor will observe the signals, and scoreboard for checking purposes. It has some built-in features uh, it will provide transaction level modeling for communication uh, between components and the factory mechanism. Once we write test bench component. Once we write test bench for components, later we can override them without changing the main functionality, and also it supports functional coverage. Mm, and also it has some RAL model also it will support.
Okay.
And
Remaining
also
any
it has
answers?
some config DB, central config DB also. It is used to store and retrieve the data.
Mm, okay. Okay. Good. We will cover all these concepts tomorrow or in the next session. Okay. Any other answer? Can anyone explain what is factory registration, agents? In system verilog, actually we don't have agent. Actually, we have a word agent where the generator, driver, monitor can sit into the agent, but we don't use in system verilog. But in UVM, we use the agent where sequencer, driver, monitor will sit in this. And top level is environment. In environment, we have the scoreboard, and top level is the tester. In test we have the sequence. What is the main difference between sequence and sequencer?
Sequence is like a object and sequencer is like a component. Sequence you use it to generate stimulus for a DUT. Um, yeah, and we will send the transactions to the driver via sequencer. Sequencer it acts
Okay.
as a bridge between sequence and driver.
Okay. So sequence is nothing but like a generator where it have a number of test cases. We can write test 1, test 2, test 3, same inheritance concept. Whatever uh, another thing is sequence item. What is the sequence item? Sequence item is nothing but which replace the transaction class. In generator, in system verilog, we write the transaction class, right? This transaction class is replaced by sequence item. Whatever the variables we put in this the transaction class, those are the sequence items, nothing but constructors, variables, members, arguments, different names are there. Okay. So this sequence is connected to driver via sequencer. Sequencer is a mediator between the driver and the sequence. Okay, so that is only one change we have in UVM test bench, whereas the UVM totally it's a methodology. Methodology means whatever the constructs are there in system verilog verification, those are designed into the standard methodology after best practices of from engineers, from scientists. They make some standard constructs which are called as methodology, where the programming is plug and play manner and also more reusable. We do not develop everything from scratch like system verilog. We can everything call from the libraries. In UVM, everything we write in the libraries. Okay. Hello. Okay, just have a revision on these concepts. We will discuss next session for UVM. Is that fine, everyone?
Yes.
Yes, ma'am.
Okay. Yeah. Okay, then thank you all. Bye.
Thank you, ma'am.
Thank you.